Hello there. Welcome to this short little video segment in which I'm going to try to contrast two ways of charging an object. I'm going to be describing like a metal sphere in this case to impart a net charge on it. The first way I'm going to show you here, it's being animated and I'm going to talk you through it, is what's known as induction. And you're seeing the very end here. You're going to start over. And what you'll notice is we'll start with a neutral metal sphere. There it is there. You can replay this as you need to. And here we bring a negatively charged wand up close. And notice how it polarizes that sphere, drawing the positives towards it and the negatives away from it. And then this will replay in just a second here. You notice what you saw a hand up there and touch it. But the first thing to see is that that negatively charged wand never did touch the actual sphere. If it touched, that would be known as conduction. But this is just induction. So there it comes up close, polarizes the sphere. Now those negatives are trying to get away from that wand. And by touching it with a finger or a wire or some other way, we've created a path off of that sphere. So the electrons, because in a metal object, those electrons are free to move around. By touching it, they are able to go into what we call the ground. Now, that might actually be a person, it might be a big other metal object, but nevertheless, they're off of this sphere as soon as that contact is made, as long as the wand is still up close to drive them away. There they go. And then we take that contact point away and then pull away the wand, and notice how the positive charges, instead of being pulled to the left, will now evenly redistribute. And you'll notice that the entire sphere is now positively charged pretty uniformly across its surface. So you see here a couple key points: no contact, and notice that the end result is a positive charge on the sphere, and that's because we used a negative wand. We could do this whole thing over again with a positively charged wand, and then the end effect would be a negatively charged sphere. That's one of the hallmarks of induction, is that your influence, whatever you use to influence on the wand, that the object will come out with a opposite charge as what you used on the wand. So there's one example, and I'm going to show you another example over here. Here's two metal spheres that start out neutral and touching each other, and then we're going to use a balloon instead of a wand. And notice how now the polarization happens across both spheres because they're in contact, and then as soon as we pull one away, we lose that contact. And so if we separate them and then pull away the balloon, now what we've done is we've polarized these two spheres, leaving one of them positive and one of them negative. So there's the electron movement. Remember, the positives are pretty much stuck in place. Even though we show them as though they're attracted to the left there, they really are fixed in place. Then, while the balloon is still up close, we move those apart from each other, and then when that influencing balloon is moved away, we've induced a polarization, and therefore both spheres end up being charged. One thing to notice here is, because we used a negative charge brought up close to the leftmost sphere, that's the sphere that will acquire the positive charge, and the rightmost sphere will acquire the negative charge. And that all has to do with that repulsion of the electrons away from that influencing balloon. So if you need to replay these again, these animations, these are courtesy of physicsclassroom.com, one of my favorite websites that I used for my first year course, and it does a great job animating the small effects that cause the induction of the charges on these spheres. So hopefully that was helpful for you, and good luck in your study of electrostatics.